Hello and welcome to Tuesday's maths session. So today we are carrying on with multiplying our fractions. So yesterday we looked at multiplying fractions by other fractions. Today we're going to move on and look at multiplying fractions by whole numbers. So as a little warm-up to remind you of what we did yesterday, there are 5 questions on the screen. I would like you to work out the answers and simplify them. Now, I'll give you a clue. Not all of them can be simplified, but you'll need to use your factor bugs to be able to simplify them. So pause the video and have a go at the answers. Okay, so first of all, we've got 4/5 times 7/8. So we've got 4 times 7. Gives us 28, and I'll try my best to draw my fractions. So we've got 28, 5 times 8 gives us 40. So before we simplified it, we should have 28 40ths. Now, if you drew your factor bugs, you would find the lowest common factor, so the smallest one that comes up in both, is 4. So we can divide 28 by 4, which would give us 7. And then we can divide 40 by 4, which would give us 10. Okay, so the first answer simplified is 7/10. Then we've got 3 times 9, because we're timesing the top numbers, would give us, I'll just draw it over here a little bit, 27 40ths. And if you drew your factor bugs for 27 and 40, you would know that there are no common factors. And so 27 40ths is the smallest number we can get for that one. So that answer would stay as 27 40ths. Then for the next one, we've got 1 times 4, which would give us 4. 2 times 5, which would give us 10. So if we're looking for common factors, we would find 2. And we know that 4 divided by 2 is 2. And 10 divided by 2 is 5. So this answer would be 2/5 as simplified. The next one we've got, so we've got 6 times 13, so this is going to be a big number, would give us 78. And then we've got 8 times 15, another big number, which would give us 120. So this one might have been a bit trickier to work out our common factors, but I'm sure we all managed to do it. And the smallest number that is in both factor bugs is a 6. So then we'd have to do another sum, because we'd have to do 78 divided by 6, which would give us 13. And we'd have to do 120 divided by 6, which would give us 20. So a simplified answer to that one would be 13 20ths. And then our final warm-up question, so we've got 3 times 2, which would give us 6. We've got 10 times 5, which would give us 50. So it would give us 6/50ths. And then we'd look for a common factor in both, which would be 2. So we do 6 divided by 2 would give us 3. 50 divided by 2 would give us 25. So hopefully you managed to get all of those right and work them out, because we're going to need some of those skills for what we're doing today. So let's get started. So what we're going to look at today is timesing a fraction, like 1/4, by a whole number. And we're going to have a look at some word problems together. So Trevor shares 1/4 of his toy cars with his friend Billy. if he has 12 toy cars, how many toy cars does Billy get? Now, even though it's sharing, which might make you think of division, because we're working with fractions, we're actually timesing. So he's got 12 cars and he's going to give a quarter of them away. And we need to work out what a quarter of 12 is. So what we do is really simple. So we've got 1/4 times 12. And we're going to use our skills from earlier. So 1/4 times 12. Now we know 12 as a whole number is the same as 12 wholes. Yep. So we haven't got quarters of these cars. We haven't got thirds. We've got 12 whole ones. He hasn't cut them up. He's got 12 whole cars. And so to express that as a fraction, we put the 12 on the top and it's 12 whole ones. So 12 ones. So 12 wholes is the same as 12 over 1. Okay. And that's just a rule that we have. Okay, because we know that 1 is 1 whole, and we've got 12 whole cars, so we've got 12 over 1. So we just take this whole number and we put it over 1 because it's wholes. Then we can do exactly what we normally do. So we can do 1 times 12, which would give us 12, and 4 times 1, which would give us 4. Okay, so we convert this whole number into a fraction by making it 12 ones, and then we times across the top and the bottom like we were doing yesterday. Now we know that 12 fours is something called an improper fraction, which we looked at last week when we were adding and subtracting. So to simplify it, to turn it into a proper number, we need to turn this from an improper fraction. And to do that, we need to use our times tables. So we're working with 4s. So we need to find out how many 4s go into 12 and if we have any left over. So I'm going to look at my 4 times table up here. So 4, 8, 12. Now I know that 4 goes into 12 exactly in my times table. So I can get 1, 2, 3 lots of 4 into my 12. So 3 becomes my big number, like when we did our mixed numbers with adding and subtracting. And I haven't got any left over because it goes in exactly. So 1/4, he shares 1/4 of his cars. So he actually gives him 3 of his cars is the answer. So hopefully that makes sense. And we'll do a couple more to practice. So let's have a look at another one. So Pammy needed 3/4 cups of chocolate chips for each batch of cookies she wanted to make. If she wanted to make 5 batches, how many cups of chocolate chips did she need? So again, we've got a fraction and a whole number, and this time we need to work out how many. So we're not sharing out, but we're working out how many lots of 3/4 she needs to bake 5 batches. So we've got 3/4 times 5 because we've got our 3/4 here and she wants to make 5 batches. So we do exactly what we just did with the other question. So we turn 3/4. So we keep that the same. And she wants to make 5 whole batches. And whole is the same as over 1, which gives us the sum 3/4 times 5 ones, 5 wholes. So then we do 3 times 5, which gives us 15. And we do 4 times 1, which gives us 4. So again, we have got an improper fraction, which we always will have if we're doing this, because we're effectively keeping the bottom number the same by timesing it by 1 all the time. So we're working with quarters again. So we need our 4 times table, and we need to see how many lots of 4 we can get into 15 without going over 15. So we've got 4, 8, 12, 16. Now I'll stop there because I know I've already gone over my 15. So I need to work out how many 4s I can get in before I reach any number bigger than 15. So I've got 1, 2, 3. If I had an extra 1, I'd be going too big. So I can fit 3 whole lots of 4. So 3 becomes my big number because this is going to turn into a mixed number fraction like we did last week. So far I've taken 12 out of my fraction. So I'll do a little sum over here. So I had 15 first of all. I've taken 12 away, which leaves me with 3, a remainder of 3. So I know that 3 is going to be the top of my fraction because I've got 3 wholes, which would get me to 12. My extra 3 go on top of my fraction like we did last time, and I'm working with quarters, so it would be 3 3/4. So we turn it into a mixed number, so simplify by turning it into a mixed number like we did with our addition and subtraction last week. Okay, let's do a couple more. So 1/3 of the children in the Carmichael family are boys. If there are 12 children in the whole family, how many of them are boys? So we've got 1/3 and a 12. Now, I want you to pause the video and have a go at doing this independently by yourself first of all. Okay, so the sum that we've got, so we've got 1/3 times 12, which is the same as 1/3 times 12 wholes, so 12 ones, because we've got 12 whole children, no children in half. They've got 1 times 12 equals 12. 3 times 1 equals 3. So we've got 12 thirds. Then we're going to use our times tables. And again, we need to use our 3 times table this time because we're working in thirds. So 3, 6, 9, and 12. So I can tell by my times tables, I can get 3 exactly into 12 this time. So I've got 1, 2, 3, 4 lots of 3 make 12. So the answer is 1/3 of the children in the family are boys. There are 12 children in the whole family. How many of them are boys? So that 4 of them are boys because that would be 1/3 times 12. So hopefully you got that one right. Give it a tick. And then final question. So Mr. Winchester ordered enough pizza for 6 people to have 3 slices. If the pizzas are cut into 8 pieces, how many pizzas will his family eat? Now this one's a bit different because we've got 3 numbers and it doesn't actually give us the fraction. We need to infer, we need to work that out. Now we know that there are 6 whole people. So we know that our fraction is going to be times 6 because there's 6 whole people. Okay, so I can cross that bit out because I've used that number. Then there's 6 people and we want them to have 3 slices each. But the pizza is cut into 8 pieces. So if we use our inference, they want 3 slices out of 8. So our fraction we're working in is 3/8. So for all 6 people, they want 3/8 each. So each person has 3/8 of a pizza. How many pizzas will his family need to eat? So now we've worked out our fraction that we're working with. Pause the video and have a go. Okay, so you should have got 3/8 times, not equals, times, and then we've got 6 ones. We've got 3 times 6. 3 times 6 would give us 18. 8 times 1 would give us 8. And then if I use my 8 times table, I can get 8 in whole 2 times, and I would have 2/8 left over. So hopefully you got that answer. And now you are ready to move on and have a go at the worksheet. So good luck and let us know how you get on.